The segment below is meant to output all factorial values from 1 factorial to 6 factorial. Recall that factorials should yield these values. 1 factorial is 1, 2 factorial is 2 times 1, 3 factorial is 3 times 2 times 1, and so on. However, this code contains at least one error. Can you find it? Correct. The variable int n is not initialized. Because we want the program to calculate 6 factorial, we will need to initialize n to 7, or change the loop condition from I is less than n to I is less than or equal to n, and then we would initialize to 6. So now the program will run with no errors. Let's try it. Do you get the values you're expecting? While the program ran without errors, it did not run correctly. Factorials multiply prior values, not add them. Also, once the operation changes, so does the initial value of int fact, or we will be always multiplying by 0. This version of the code will run without errors and correctly produce the expected factorial's values. Once you learn to create reliable code, it's time to think about efficiency. Consider the sum of 0 factorial plus 1 factorial plus 2 factorial, and so on. There are at least two approaches. Compute n factorial and write a loop to sum n of them. Compute n factorial each time as n times the last one, only a single multiplication. Both ways are correct, however, number 2 will have a much shorter segment of code. This becomes more and more valuable as our programs get larger. How many times does the program go around these loops? The loop with I runs 6 times, but within it is the loop with j, which runs 5 times every time the I loop runs, which makes a total of 30 times. How many times does the program go around these loops? We don't know, as n is not initialized, so the program will have an error.